Hello and welcome everybody to this session of Di2020 2020. Thank you for coming. Hope you're enjoying the event and moving around with this 7-bit cool user interface created specifically for it. So let's go with it. A bit of virtual logistics first. Everything starts in Piazza Lazaretto. That's the piazza you accessed when you logged in. Is the first screen where you can access all sessions from other years, even from this year, the one-to-one sessions, even live music. You can leave your questions on the chat on the bottom right of this screen, and I will try to answer everything at the end of the talk. If not, if we want to have a one-to-one session, you can access the room from Piazza Lazaretto in the beginning, and I will be there until 7 after this session. Also, a reminder that all these sessions are recorded and will be published, so you will be able to check them out later. A bit of the agenda. Well, as you already know, infrastructure deployment has been changing a lot over the last few years. Actually, it has been changing continuously, but in general, it is difficult to keep up with it, with this speed in most cases. The agenda for this session is pretty simple. We're going to do a review of what it means to get involved in an infrastructure as code project and some considerations and recommendations that I would like to share based on my experience. About me, well, I got my first computer when I was 15 years old. I started coding in C. Since then, I've done quite a different things related to IT. The most relevant one, I've been working in backup and storage area for a long time. And a few years ago, I changed my expertise, let's say that way, to the new technologies. These are these technologies that are so popular now that in some cases are not so new because they've been around for almost 20 years, some of them. Just now I'm working for Sony in Spain as an innovation area leader and mostly involved in infrastructure as code projects. Okay, our trip around the world. Well, just to set a bit of context on this, when I started preparing this session, I wanted to think of an analogy of an infrastructure as code project. And then Jules Verne and the book Around the World in 80 Days came to my mind. Well, I haven't read it in a while. I don't remember all the details, but the basic story in this adventure that I enjoyed when I was younger is that Mr. Phileas Fogg reads in the newspaper an article that claims that now it is possible to travel around the world in 80 days. After discussing it with a friend, they got and make a bet, and he takes on this trip. To be honest, it didn't seem to me as different as when I read my first article about infrastructure as code, and few months after I started my first infrastructure as code project. One of the things I've been experiencing on the way to do infrastructure as code, as well as Mr. Fogg in this book, is that there are a lot of unexpected and complicated situations to face on the way, and plans had to be changed quickly in order to finish our quest. For Mr. Fogg, what would be schedules that are not accurate, for example, trains that don't even exist, a herd of buffaloes in the tracks at some point, or having to decide between two methods of transportation with no information whatsoever of the security about them or even the speed. Some problems with some police agents chasing them, things like that. Maybe that sounds familiar in some of your projects. Well, there is an important advantage in the case of infrastructure as code projects, is that in the case of Mr. Fogg, nobody has done it before. In our case, many people, or at least enough people, has done these projects before. so we know it can be done. Okay, let's get a bit of background around infrastructure as code. Okay, as I mentioned, infrastructure deployment has changed since the way it was done when many of us started working in IT. Even if you haven't started long time ago, you might have ended with a customer or in a project where infrastructure is somehow managed the same way as I'm describing now. That is why basically in the past, when you wanted to deploy an application, you started by selecting the proper hardware from the vendor to run this application, and you give it a name, you install the operating system, you configure it, you tune it, you install your application, again, configure it, and doing some configuration to make it work perfectly. And then you maintain this server and this application for the rest of the life cycle, that it could be till the end of the support of the vendor for the hardware of the application, or even longer than that. Well, this is what you usually would hear defined as pets in this context. Now, there is a big problem with this. Treating our infrastructure as individual unique objects become unmanageable really fast when the business grows, because as the number of these unique objects increases, so it does the operational effort to manage them. But this operational effort grows exponentially. Infrastructure as code basically appears as one of our saviors from all of this, allowing the IT departments not being a bottleneck for the business growth anymore, and going from a traditional pets scenario to the other well-known concept of cattle. And this is what most of infrastructure projects as code projects are about. The other well-known use of this infrastructure as code is when we are adopting cloud infrastructure. And in those cases, maybe the challenges are not so, let's say, problematic, even though there are other challenges. Well, as the name for this slide is everything as code, well, when we're talking about infrastructure as code, we're thinking of maybe the servers, maybe we're including some like networking devices there. Okay, but in a landscape where we're talking about everything as code, what we're actually referring to is that every process in our IT department can be treated as code and maintained that way. We're talking about documentation, testing, things like that. Basically, like everything in the daily life of an IT department. Okay, some recommendations to start with this. Infrastructure as code is a trending topic just now, so you can find a lot of information on the internet, good sessions and articles and all kind of documentation about like specific tools, generic infrastructure as code, etc. But my recommendation to start, if you haven't really started working with it, is this book, Infrastructure as Code by Keith Morris, that I have here. It's actually, a new version is actually being prepared, so it might be ready this year, a new edition. Really recommendable from my point of view. Another interesting talk from Brickman at HashiCorp 2018 called 5 Lessons Learned from Writing Over 300,000 Lines of Infrastructure Code. Gives a really interesting point of view also on all of this kind of project. And of course, if you're going into a project of this kind, or you're getting started with infrastructure as code, I wouldn't do it without reading Around the World in 80 Days. This, by the way, is the original cover from the French version that Jules Verne published initially last century. Okay, one of the first or the main concepts I wanted to clarify here it's a bit of the difference between infrastructure as code and automation and the relationship. I was thinking to do it as a similarity with trains. Okay, when we have a train and we have the machine, we can think of starting to transport people, and we know that trains are the essential part of it. But in order to create a transport system, there is much more around it. We need to decide, for example, where trains are going. We need to build the train stations. We need to build the tracks to get there. We need to choose drivers and train them. Or if we're creating autonomous trains, we need to implement the code that makes them autonomous. We need to schedule drives. We need to have a group of engineers that are in charge of fixing these trains, maybe improving the designs, make them more efficient or faster, etc. Well, what is automation? In the most simple way, automation is just doing some task without manual intervention. It could be from connecting to a server to run a shell script, to connect to a website, push a button that leverages an automation, or even an automation can be triggered by an alarm in some system. So the basic benefit of automation, and the clear one, is that we get rid of manual repetitive work, and that way we reduce also the probability of human error. When we think of infrastructure as code, though, we are going from the trains to the transport system. Automation is the most essential part, of course, but we need to solve and engineer many other components. If we want infrastructure as code to actually happen, we're going to need to implement processes and train people on how things have to be done from now on. Manual configurations are not going to be allowed, for example. We need to deploy new tools that empower the use of automation to create an ecosystem of IT work that we can trust. That means we need to have processes for authentication and authorization. We need to audit what's happening with automation and what is happening. We need to understand how these processes are affecting our infrastructure, and more. And one important thing is that once we enter into infrastructure as code, this code that configures our infrastructure becomes an essential asset of our IT department and is one of the most critical parts of our business. So we need to treat it and consider it as such. Okay, some ideas about infrastructure as code and basically the foundations of these ideas. Well, concepts around infrastructure as code might be well known. For example, immutability of infrastructure, configuration drifts, snowflakes, things like that, and just concepts. But what is more important is the ideas behind that are the important thing to keep always in front of us and to guide the decisions we make around it. One of them is that everything must be easily reproducible. That also means that our system has to be disposable. One and the other one really interconnected. Another one that is really related with it is that systems must be consistent and no individual manual changes are allowed on these systems because everything has to be repeatable and reproducible, as we said. So any change has to go through a process of automation and testing that verifies that this configuration is acceptable in our infrastructure. And another important idea that we cannot forget is that the design of our infrastructure is going to be always changing and adapting to new needs. That means the code for our infrastructure is going to be a dynamic entity that we need to be updating and maintaining continuously. Okay, getting ready for our first or not first infrastructure as code project. Well, before we get into a project, it's good that we stop and think about what we're gonna find in front of us. I'm giving you an 80 days scope as the good number for a minimum viable product. Depending on other factors, this might be even a short term. But in most cases, we can think of 80 days as a good number for it. If you work with Scrum, maybe you can think of 8 standard sprints for Scrum. And 80 days is obviously not a must, but it's a good starting point to think about. No matter if you are the service in the services company providing the solution, or if you are doing it for your own company, there has to be some things to consider and prepare for these projects. One is the maturity level that we are at the moment. Another one is make sure you use agile ways of managing your project. You need to choose an appropriate team for this job, and you have to be aware of all the challenges that are going to be in front of you. With all of this, even though it's complicated, you probably are going to be well prepared to set this initial scope for your project. Okay, let's talk about maturity levels. Just to give you an idea how to evaluate these maturity levels, we can start with maturity level 0. In this case, we have that everything is mostly manual. Automation doesn't really exist in our infrastructure. Maybe some individual sysadmins have quite good self-scripting in place, or have started playing with something like Ansible to help the daily tasks, but as a personal decision. The code is not really shared or maintained in a formal way. Another indicator is that testing is all manual. Many times, these tests don't even exist because there is no time for them, for example. And the procedures of testing anyway are not documented, written down anywhere, and it's up to the person testing at the moment to decide what to look for. Deployments and patching of this infrastructure takes usually weeks of planning. It's done few times a year because it's like really costly, and because there's a lot of unknown outcomes of it. We're talking about like fixing problems in place, extra hours, systems down, rollbacks, things like that. Another thing is that usually application owners are able to customize every single tweak of their systems, and this customization is not tracked anywhere. Getting things working here usually means fixing failures in place. All unsupported systems hold critical applications and are part of the core infrastructure. It's a common scenario here, and the problem is that these systems impact one way or another most of the internal projects in IT. That's also known as fragile infrastructure. A CMDB, if it exists, is usually not reliable. And if you want to know anything about the system, you have to like connect to them, or you have to contact the owner of the services to gather information about it. Okay, next level 1. Well, in this maturity level, what we're gonna find is some kind of level of automation, and many systems and applications have maybe templates to deploy them. The only problem here is that after deploying them, manual changes are still common, and configuration on day 2 of the deployment is not tracked. That is called also known as configuration drift. There are probably critical systems with all configurations, but this critical system might not be might not impact so much every IT project and as before, and even maybe there are plans to decommission them eventually. These are the famous snowflakes. Next level 2. In this case, systems and applications are deployed in a really well-controlled way with well-known configuration. CMDB is updated frequently, and IT processes are well documented and in some cases automated. Some level of automated testing is in place, And more important, configuration are mostly consistent all over the platform, especially for critical applications. Updating and patching of the systems in this level is done as needed without a lot of suffering from the operations team. And our last level is level 3, where mostly we are ready or almost there. We are almost implementing infrastructure as code, and it's probably just a matter of refining some processes or adopting some extra solutions to complete the whole solution of infrastructure as code. Every IT process is automated and auditing information is collected, for example. And maybe we can improve a bit on observability, on changes on our platform. We can get better CI/CD pipelines, or take them further to get things to production faster. Maybe we can use. We're not using or we're not integrating security processes still from the beginning in our solutions, things like that. Okay, another way of looking at this maturity level or preparing for the scope of our MVP is trying to respond to some of these questions. In this case, one of the most important one, in my opinion, is starting up the provisioning of the basic provisioning of infrastructure, and take from them to a more complicated areas. Basically, containerization, virtualization, networking, microservices, continuous integration pipelines, observability platforms as tools, how we use API integrations, if we use them at all, if we count already with a version control system and people know how to use it. Things like that are going to be indicators of this maturity level. Okay, be agile. Well, if you're used to set the scope and time planning of the whole project you're involved during or before the analysis phase, and you just wait for it to finish to see if the scope was right, or actually you don't deliver with much delay, you're mostly in the same situation as this guy here, especially if you try to face an infrastructure as code project like this. Agile has been around for a long time now, and probably all of you have at least heard of Scrum, Kanban boards, things like that. But especially how important it is the cycle of short iterations, and including test and verify with the final user in every single cycle. I'm not gonna go deeper on this. I'm not an expert either, but setting achievable objects is important, and making sure those objectives are accurate is what gives you an advantage on a long-term project. Well, another reason to use Agile is that when you start the project of infrastructure as code, as for example, when you want to go to the moon, but you haven't started engineering what traveling around your own, let's say, continent looks like, you might get the wrong picture of how to get there. You might need to go step by step, solving smaller challenges until you are actually ready for your last stop. It is okay to have in mind that we want to get to the moon, but we might have to engineer and solve transportation with closer destination first. If we're still managing steam engines, for example, we're going to need a while to develop the engineering for rocket science to be able to land on the moon. So yes, my take for this is keep in mind that your original picture, where you're gonna go, doesn't always solve the how you're gonna get there. Okay, choosing the right team for this kind of projects. Obviously, if you have experience with a team, then go ahead But some ideas around this is like we might have a great team, good intentions, they're adorable, and we like them. But there might be a team that is not really focused on the task, and they might not understand the whole picture of the project. We might have another team of guys, this case, that there's no doubt that these guys are really experienced. There is a lot of teamwork here. They're really resourceful and experienced. We can trust that they will get the job done. The problem, though, is that for this kind of projects, they might tend to be a bit destructive, and the production services might not take that well. On the other hand, we can try to find a balanced team, maybe with a more limited experience, but with really different skills, and with an open mind that is like basically eager to learn new ways of doing things. I let you decide what would you like for this project. Last for getting prepared for this is the challenges. There are like few challenges I would like to talk about here for these infrastructure as code projects. These are your enemies, quote unquote, that you're gonna have to be aware of from the beginning, and they might actually impact your project, and being able to handle them can be the difference between success or failure on this. The first one I want to mention is change resistance. There are many causes of it, and I think most of us know how they look like. But the problem with this is that you're going to be there is a lot of change related to infrastructure as code, and you're going to be dragging back and forth in a lockdown situation where your project is going to be kind of stuck. Scope not being clear for everybody. You might have like a really good set scope with the person you are talking to, but in infrastructure as code, usually several teams are involved, and different teams have different objectives and incentives. So it is important that the scope and the motivations are clear for everybody that you're going to have to be working with, because if not, you're going to lack a lot of motivation from those teams in helping you. Inside knowledge. Well, related to the sign-ups before, you're going to be dealing with different teams with different expertise and different areas that you might not be an expert at. And even if you're an expert, they don't really happen the same in every situation or every IT department. So you're going to need somebody, you're going to need like a technical champion or process champion or somebody from those teams that actually help you verify that what you're doing is right or how you should be doing it. So make sure you like get them aboard in your team or are collaborating closely with it. Technical debt. Technical debt could be because we are inheriting something that was there before, or because the urgencies of the project are making us skipping testing phases. Well, you should avoid always at all any technical debts or any risk of inheriting technical debts for this project. Basically, the only way of solving a technical debt in the future is going to be stop production and tackle it and take a lot of time, and it's going to impact the business a lot if you leave it there. So keep away from it. Heavy processes. Well, this usually happens in traditional and well-audited companies. The burden of change management can impact severely the capacity of your team to work. and to do their job. The only way of easing this is to identify these processes way in advance and basically get the collaboration of all the stakeholders that can help you prioritizing the work. Critical systems, the snowflakes we were talking about in the maturity level. Well, try to stay away from them until you know them better. Eventually, if you have to deal with them and you have more expertise in the situation, the customer, the architecture, it will be easier to solve the problems. One thing I call the problem of the busy place. Well, if you go into a situation where the IT department is basically putting out fires every single minute of the day, and they might not even have enough people to fix all their problems, that will be a direct consequence of all technical debt. The problem that you're going to face here is that you're not going to get your champions or your collaboration for the teams easily. So be aware of that because that will require a lot of talking and convincing stakeholders to actually dedicate resources to your project to have a proper outcome. The last one, all tooling. Well, you might find that there are some processes or tools in the customer or in your systems that are not automatable. So just accept it. They might be or they might not be on the way out, being substituted. But if they're not, you're just going to have to accept that some parts are going to have to be manual, and the only solution is to actually document well enough the procedures that fit with the rest of the solution that you're giving to this project. Okay, things to keep in mind when we are in the project. First of all, this is not about the project itself. It's about, but it's going to affect during the project. In many cases, your team or yourself are going to come from a sysadmin background. And no doubt that for a pure developer, there is not so much to change. But for everybody else, we have habits of doing things in a CLI and a user interface, and it's going to be difficult to avoid doing it because initially, especially at the beginning, we're going to feel like we could be done much faster with the traditional way. Well, I'm just gonna enumerate few of these things. One of them is the classical concept of if it works, don't touch it. Well, as we saw before, infrastructure as code is about like evolving and changing and making new changes and making things better. So basically, even if it works, touch it, make it better, and check where you can improve what you have. If you actually are afraid that this might impact your production server or your solution, keep an eye on your testing infrastructure, because that could actually mean that you're not having a reliable testing solution. The monolith script. If you ever program a bit or you did shell scripts, you're gonna be probably used to do your own script in only one file. Well, in these kind of projects, you're gonna be sharing code with many other people and many other teams. The best practices for coding has to be put in place, and obviously monoliths are not one of them. But you're going to have to learn a bit about coding best practice, basically. And the last one I want to mention is like probably as an infrastructure person, you kind of like document your knowledge. I don't know if in a text file or something more fancy. But in this case, all this knowledge and all this information, it's something that you should actually learn to use with Git or with a version control system, because one of the main things that can help your team is to share all this knowledge, and the best way of doing it is with tools like that. Okay, the tools, and this is like basically the infrastructure around the infrastructure as code solution. First of all, well, the automation tools, or we can call it the automation platform. It is the heart of our solution, and it's going to consist of a group of tools that allow us to effectively run all the automations. So it's not only this language, it's all around this language. It's about having the right tools for provisioning infrastructure. It's about having the right tools to configure infrastructure. It's about integrating with authorization and authentication systems. It's about having the proper repository for software or other artifacts and being able to track and version them. Some things might already exist. Some things might need to be put in place. Version control system. Basically, you're going to have one solution where you're going to be able to upload and share your code for the infrastructure. This could be any of the solutions in the market, most of them based on Git. CI/CD, well, this is about having a proper and reliable testing system. Again, you need to test everything you do before you send it to production. Observability. Well, all the information related to every change in your platform should be easily consumed. From auditing changes to evaluate, from auditing changes in infrastructure to evaluate how these changes impact our services, applications, hardware, etc. That's what this platform is about. And the last one, it's our source of truth. Well, I'm saying here source of truth and not CMDB first, because CMDB in many cases feels like something untrustworthy because it's not usually updated or not complete information. It could be a service mesh, but in any case, it's basically that piece of our platform that gives us the information of what our infrastructure looks like now, or what it should look like when we deploy it. Important thing to do during our projects, managing snowflakes. Well, snowflakes are there for a reason, or at least that's what people in charge of them believe. In general, they're related to fragile infrastructure, but it is important to detect fake snowflakes that acquire that condition in our infrastructure because maybe lack of maintenance or lack of expertise, and they're not actually so fragile if we know how to manage them. These cases we can probably help by getting the expertise on board, or testing enough to make them actually convert them into templates and reproducible infrastructure. In other case, they are actually critical, difficult infrastructure to manage. They're usually going to have tough defenders because it's usually their pets, and they have a lot of fear and resistance to touch this infrastructure. The way to solve these problems usually is by surrounding these snowflakes of good, reliable automation that start building trust to think of this migrating these snowflakes into an automated manner. Okay, Nifophobia. I hope I pronounced it more or less well. Most of infrastructure as code tools are really well tested and prepared for cloud native environments. But many real-life scenarios are going to include classic data centers where not everything is so cloud-friendly. Nefophobia is basically being afraid of clouds. Some of the problems here are going to be that not all traditional applications have complete CLIs or APIs to be able to automate operations and configuration of them. That could be, for example, the old tools that we were mentioning before. Some of them might not have configuration files properly documented. This is common, especially with vendor products that are supposed to be managed by their professional services. Most of these traditional applications won't have secure integration for these CLIs, and it's our job to find the best solution given the circumstances or implement additional tools to integrate securely. At some point, we will have to choose to keep this application out of the infrastructure as code solution and ask to be substituted with more modern solution. But anyway, that usually knows the best news to give to the IT departments behind their management, because it means more investment. Okay, don't forget about security. Quickly, this is probably not the first time you heard it, but security must be part of the solution from the beginning. We are automating processes, and anything that is not in the code is not going to happen. Don't leave the hardening for somebody else at the end of the process. Networking security is part of the infrastructure. Proxies, firewalls, open ports, system configuration, vulnerability scans, and remediation should be part of the solution. If you're not familiar with it, check out Zero Trust Network, because it's a really important way of doing things nowadays regarding network security, especially. Another thing to think about is is your observability platform giving you enough information about the security aspect of the changes in your infrastructure? Disasters. Well, it's good that we create a really nice infrastructure code solution, but we had to count on how to recover from disasters. Disasters happen many times, unexpectedly and naturally. Other times, some human intervention. In any case, we need to be ready for that. If you have chaos engineering, this is what we're talking about. Check it out if you don't. But the outcome of this is you should have always your DR plan ready. You should have it tested, and you should be able to identify what situations are you covering and how are you gonna recover from them. Again, these DR scenarios and how to fix and how to recover from them, it's another dynamic and evolving part of your infrastructure solution. Well, we got to the end. Basically, this is kind of like a scary trip when we got into that, but even though it's a challenging trip and a bumpy ride, it's really interesting to get into that. So I just had to say that you should enjoy the scenery as you go along, have fun and enjoy and learn from it. Okay, thank you very much for attending. I'm gonna check if there is any questions. Okay, don't see any questions. Then please, if you have any other questions, I'll be in the one-to-one room after 2 minutes. You can come along and ask me anything you want. Thank you again for coming, and enjoy the rest of the sessions that you intend to attend. Thank you very much.